Jai Hind students, welcome to my YouTube channel. Students, focus on making yourself better, not on thinking that you are better, right? So basically students, the road to success is not easy to navigate, but with hard work, drive and passion, it's possible to achieve every dream. Clear students? So always remember, success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all students, love of what you are doing or learning to do. Clear? So with that students, let's start this session. In this episode, we are going to concentrate on numericals, which are based on law of conservation of linear momentum, right? So let's recap the topic of conservation of linear momentum. Students, we are aware, as per Newton's second law, the time rate change in the linear momentum of a body is directly proportional to the external force applied, and the change in the momentum of the body always takes place along the direction of the force applied, isn't it? We all are aware of it. So mathematically, Newton's second law can be written as F vector is equal to dp vector divided by dt. This is the time rate change in the momentum of the body, and this change in the momentum, it always takes place along the direction of the force applied, isn't it students? Now suppose in a system, if the net external force acting is 0, let net external force acting on a body or system is 0, then we may write it like this: dp vector divided by dt is equal to 0, isn't it? So if the net force acting on a system is 0, then the time rate change in the momentum of the bodies constitute the system must also be 0. Now as we are aware, differentiation of constant is always 0. So from these two facts, we conclude that P vector is equal to constant. That is, initial momentum of the system would be exactly equal to the final momentum of the system. So this is basically, students, the law of conservation of linear momentum, which states that in the absence of any external force, the total momentum of the system is always conserved, which suggests that total initial momentum of the system is exactly equal to the total final momentum of the system. So it is on this fact that these four questions are based on, right? So let's apply this concept of law of conservation of linear momentum in solving these questions. Right students? So let's start with the first question, which is a very interesting one. I'll read the question for you. A body of mass 10 kg, which is initially at rest. So initial velocity of that body is given to be 0, right? So a body of mass 3 kg, initially at rest, explodes and breaks into 3 fragments of masses in the ratio 1:1:3. The two pieces of equal mass fly off perpendicular to each other with a speed of 30 meters per second each. We are supposed to find the velocity of the heavier fragment, right? It's a very interesting question. So first and foremost, what we do is, the mass of the body is 10 kg. Mass of the body is 10 kg and it explodes into 3 fragments. Let us find out the mass of each of these 3 fragments, right? Mass of first fragment. Mass of first fragment. The ratio is 1:1:3. So 3, 4, 5. So 1/5 multiplied by 10. So it will be equal to 2 kg. Am I clear students? Right? Similarly, mass of second fragment. It is also 1/5 into 10. It is 2 kg. And the mass of the third fragment is ratio is 3. So 3 by 5 into 10. So it will be equal to 6 kg. These three fragments will combine together to form 10 kg, isn't it? So the masses of the three fragments are 2 kg, 2 kg and 6 kg respectively. So this is the heavier fragment, its velocity is to be determined. And these are the fragments of equal masses. After exploding, the two fragments of equal masses fly off perpendicularly, right? So here the initial, suppose this is the initial body. This is the initial body of mass 10 kg. It is initially at rest. So if a body is initially at rest, so initial momentum of the system is 0. Momentum is mass into velocity. So if V is 0 or initial velocity is 0, then the momentum of the system initially before explosion is 0. Now it explodes. Basically it explodes into three fragments. This is suppose the first fragment of mass 2 kg. This is another fragment of similar mass of 2 kg, and they fly off perpendicular to each other, right? They fly off perpendicular to each other, and also it is given, students, the two pieces of equal mass fly off perpendicular to each other with a speed of 30 meter per second. So its speed is 30 meter per second. It is also 30 meter per second. It is 30 meter per second. Its speed is also 30 meter per second. And we are supposed to find out the velocity of the heavier fragment. So the third fragment would be like this. Its mass is 6 kg, isn't it? So we are supposed to find out its velocity. Right, students? This is to be determined. So what you need to do is, initial momentum of the system is 0. And this body of mass 10 kg, which is initially at rest, explodes because of internal forces, not due to any external force. So net external force acting on the body of mass 10 kg is 0. Therefore momentum is conserved. Therefore initial momentum of the system must be equal to the final momentum of the system. Therefore students, final momentum of the system after explosion, that must be also 0. Remember it. The body explodes due to some internal forces. Net external force acting on the body of mass 10 kg is 0. Therefore, as per the law of conservation of linear momentum, the initial momentum, which is 0, must be exactly equal to the final momentum, which must also be 0. So final momentum of these three bodies constituting the system must be 0. Right? That's the concept to be used over here. Now let us calculate the resultant of the momentum of these two. Right? Now what is the momentum of this body? Momentum is mass into velocity. So suppose this is fragment 1, this is fragment 2 and this is fragment 3. So momentum of this body would be along this direction, and its momentum is P1. It is 60 kg meter per second. Momentum is mass into velocity. So the momentum of this fragment is 60 kg meter per second along this direction. Similarly, the momentum of this body, P2, it is also 60 kg meter per second, 30 into 2. And what's the angle between P1 and P2? 90 degree. And both are of equal magnitude. Now students, we are aware, when the two vectors are equal in magnitude, then the resultant of those two vectors bisects the angle between them, right? So what is the resultant of these two? It will be bisecting the angle between these two. Suppose this is where, let me draw the diagram. This is P1, right? This is P2, and both are equal. Let P1 is equal to P2 is equal to P, say, each in magnitude is 60 kg meter per second. So what will be the resultant? It will be like this. It will bisect the angle between these two. So if the angle between P1 and P2 is 90 degree, then this angle would be 45 degree. And what will be the resultant of these two? These two vectors are inclined at right angle to each other. So the resultant of these two would be P12. It would be equal to square root of P1 square plus P2 square. Both are same. So it will be equal to root 2P. Clear, students? So the resultant momentum of fragment 1 and fragment 2 is root 2p along this direction. Clear? Now, this is the third fragment I am talking about. Now, final momentum of the entire system can be 0 only when the third fragment possesses momentum whose magnitude must be equal to the resultant of the magnitude of P1 and P2. Right? So, the momentum of the third fragment must be equal in magnitude and oppositely directed. It is only then the final momentum of the system can be 0. Right? So, what about the momentum of this third fragment? Let its velocity be v and mass is 6. So, its momentum would be 6v. It is 6v. Right? So, therefore, students, for the final momentum to be 0, for the final momentum of the system to be 0, what happens is this root 2p, it should be equal to 6p. So let's substitute the value. Root 2, what is p? The magnitude of p is found to be 60. 6 into v. So what we get is v would be equal to 10 root 2 meter per second. So this is the answer. Clear, students? So the third fragment must possess velocity of magnitude 10 root 2 meter per second. And in what direction? It should make an angle of, this is 90 degree, isn't it? This is linear here, this is a straight line, this is a straight line. So this angle must be 135 degree. Right? So in this direction, the third fragment should fly away. Right? It should possess a velocity of magnitude 10 root 2 meter per second, and third fragment must move along this direction, so that the momentum of the third fragment is exactly balanced by the resultant momentum of the first two fragments. It is only then the momentum will be remaining conserved. So this is how such questions are to be solved. So students, this was a very, very interesting question. It's a very, very important question too. So we are over with question number 1 then. Second question, similar question, just for practice. Let's again do this question based on conservation of linear momentum only. Right? Let's proceed. Okay. Second question is similar to that of the first one. During explosion, a bomb explodes into 3 pieces. 2 fragments whose masses are 0.8 kg and 0.5 kg fly off perpendicularly with velocities of 10 meter per second and 16 meter per second respectively. If the third fragment goes off with a velocity of 24 meter per second, then we are supposed to find out its mass and the direction of motion with the first fragment. Okay, this is quite interesting one. A bomb explodes. So initially, the bomb obviously would be at rest. So initial momentum is 0. So initial momentum is 0. Therefore, as per law of conservation of momentum, the final momentum of the system must also be 0, as no net external force is acting on the system. The bomb or the body explodes due to internal forces. No net external force is responsible for that, right? So final momentum must be 0. Now, this is a bomb, suppose. It explodes into 3 fragments whose masses are 0.8 kg, 0.5 kg. Suppose this is the first fragment. Its mass is 0.8 kg and its velocity is 10 meter per second. 10 meter per second. So students, what will be its momentum then? Momentum is mass into velocity, 0.8 into 10, 0.8 multiplied by 10. That would be 8 kg meter per second. Fine students? Okay. Second one is of mass 0.5 kg and fly off perpendicularly. Okay, second one. This is the second one. Its mass is 0.5 kg and its velocity is given to be 16 meter per second. So its momentum would be P2. It would be equal to mass into velocity, that is 0.5 multiplied by 16. So it will be 8 kg meter per second. Right students? And what's the angle between these two? It's 90 degree. Therefore, the magnitude of P1 is equal to magnitude of P2, this is equal to P, say. And it is equal to 8 kg meter per second. So, what about its direction then? This is P, this is P. The angle between them is 90 degree. So, whenever the two vectors are equal in magnitude, then their resultant always tends to bisect the angle between them, right? So, this will be the resultant. So, what will be the angle? This is the first one, this is the second one. So, angle must be 45 degree. And what will be the resultant? Resultant of the momentum of the first two fragments would be square root of p square plus p square. When the two vectors are perpendicular to each other, then the magnitude of the resultant is given by square root of a square plus b square, right? So it will be equal to root 2p. So resultant is root 2p. Clear students? So the resultant momentum of fragment 1 and fragment 2 is root 2p along this direction. Therefore, for the final momentum to be 0, the third fragment must be having momentum of equal magnitude as that of the resultant of fragment 1 and 2 and must be oppositely directed so as to nullify the effect of each other. It is only then the final angular momentum of the system may become 0. Right? Again, let me clarify it once again. Initial momentum is 0. So the final momentum after explosion must also be 0. Right? These are the two fragments. The resultant momentum of these two fragments is along this direction. So if the third fragment possesses momentum of same magnitude and in the opposite direction to that of root 2p, then the final momentum of the final system must be 0. In that case, it will be 0. Right? So it will satisfy this condition now. So therefore, its momentum would be mass into velocity. Suppose the mass of the third fragment is m3 and its velocity is given to be 24. So momentum of the third fragment is m into v. So 24 into m3. Right? Therefore, for final momentum of the system to be 0, this 24 m3, it must be equal to root 2p. So let's solve it. 24 m3 is equal to root 2 multiplied by, what is p? It's 8. So that will give us m3 is equal to root 2 divided by 3. Am I clear, students? So that will give us 1.414 divided by 3 kg. M2 would be somewhat less than 0.5. So it is about 0.47 kg. So the mass of the third fragment must be about 0.47 kg. It is only then the final momentum of the system will be 0. And students, angle. We are supposed to find out the direction of motion with respect to the first fragment. This is the first fragment. So with respect to this, what should be the direction of motion of the third fragment? This is the angle. This is a straight line, so it's a linear pair. Total angle is 180 degree. So this is 45 degree. So this remaining angle must be 135 degree. So what is the direction of motion with respect to the first fragment? It is 135 degree, right? So we have obtained both the answers. So this is also a very, very important question. Actually, first two questions were similar. Just for practice, we have done both the questions, right? Okay, students. Third one again, very, very interesting one. Let's concentrate on the third question now. Three particles or three bodies A, B and C it is given, and they are of equal masses. Suppose each possesses mass m, and with equal speed v along the medians of an equal triangle. Medians, they collide at the centroid G. Centroid means intersection of the medians. This is the centroid. This is an equilateral triangle, right? These are the three bodies A, B, C, each of mass m. Each of mass m. Each of the three particles are given to be of equal mass, and they are moving with equal speed v. So they are moving with equal speed v, and they meet at the centroid. This is the centroid, which is the intersection of the medians of a triangle. That's centroid. Okay, they collide at the centroid G. After collision, A comes to rest. Okay, body A comes to rest. So its final momentum of body A is 0. B retraces its path. Okay, B after collision at the center, it will retrace its path along GB, right? Along GB. So we are supposed to find out the velocity of C. It's a very, very interesting question, students. So let us find out. Let us find out the initial momentum of the system. Initial momentum of the system. Now look, students, in magnitude, PA is equal to momentum of the second body as well as the momentum of the third body, that is C. Each is equal to mass into velocity. Each body is having same mass m and velocity v. So momentum of each body is m into v, right? Momentum of each body is m into v. So initial momentum, let's get it. Okay, it is like this. This is suppose mv along this direction, right? This is p. C. This is p vector, right? I have represented this one. Now, this is another vector. This is also p. This momentum is along this direction. Momentum is always along the direction of motion. And this is the direction of motion of body C. So its momentum will be also along this direction. So I am drawing an equal vector over here. So this is also p. This is for body A. This is for body B. And this is for body C. Right, students? So as you can notice, the three vectors, they are equal in magnitude and they are forming the three sides. They are forming the three sides of a triangle, all in the same order. So their momentum PA vector plus PB vector plus PC vector is equal to null vector. So net initial momentum of the system comprising these three bodies A, B, C is 0. Right, students? I hope you have understood this concept. It could have been understood in the following manner as well. Suppose this point C, G. So initial momentum of body A would be along this direction, right? This is PA. Now, at this point, the momentum of C would be along this direction, like this. This is PC. And similarly, this is PB, right? Angle. This angle is obviously 120 degree. You can also convince yourself using this diagram as well. This is 120 degree. Now each of these vectors is of same magnitude. So what to do is, if you find out the result of these two vectors, all are equal. So at the same instant, we can't solve all the three vectors simultaneously. We get the resultant of the two vectors and then solve the resultant of the first two vectors with the third one, right? So what is the result of these two? When the two vectors are equal in magnitude and the angle between them is 120 degree, then the result is given by, it bisects the angle between them, and the magnitude of the resultant in case of 120 degree would be equal to same as that of the magnitude of either of these two vectors. So now we are left with these two vectors. So this is P, its magnitude is also P. Both are equal in magnitude, opposite directed. So net momentum over here will become 0. Right? So either by using triangle of vector addition or by drawing this particular diagram, by using vector addition. In both ways you can verify that the initial momentum of all the three bodies A, B, C is 0. Right? So therefore, final momentum must also be 0, as no net force acts on the body. Therefore, in the absence of any external force, we are aware net momentum of the system is conserved. So if the initial momentum of the three bodies is 0 before collision, therefore after collision the final momentum of the three bodies must also be 0. Right? Therefore students, final momentum of the three bodies must be 0. So suppose PA dash, this is the final momentum of body A after collision. PV dash, this is the final momentum of body B after collision. And PC dash, this is the final momentum of body C after collision. It must also be 0. Right? Now, after collision at the centroid, body A comes to rest. So if body A comes to rest, so its final momentum would be 0. Isn't it? And B retraces its path with speed V. Now B is moving like this. After collision it will retrace its path. So its momentum will change its direction. So PV dash, it must be equal to minus PV. Clear students? It must be equal to minus PV plus PC dash is equal to 0. Here, as per the question, it's given that after collision at the centroid, body B is initially moving along this direction, but after collision at the centroid, it will reverse or it will retrace its path without change in its speed. Right? So, it is given that final momentum of body B, it is equal to negative of initial momentum of body B. Negative sign represents that the direction of motion of the body gets changed without there being any change in its magnitude. Right? So therefore students, final momentum of body C must be equal to initial momentum of body B. Am I clear? Final momentum of body C must be equal to the initial momentum of body B. Therefore, MVC dash, it should be equal to MVB vector. So MM get cancelled. So therefore, VC dash vector, this is the final velocity of body C after collision. It should be equal to students VB. So both in magnitude it should be equal. Also direction should be same. What is the velocity and direction of motion of body B? It was like this. So after collision body C, which was initially moving along this direction, after collision at point C, it will move along BGE. Right? So what is the velocity of C? C will possess, I am writing the answer over here, velocity V. It will possess the same velocity V. And along which direction? Along the direction of initial direction of motion of body B, that is along BGE, along BGE. So students, this is the answer, right? Okay, now the fourth question, again based on conservation of linear momentum. A shell of mass 10 kg, a shell of mass 10 kg is moving with a velocity of 20 meter per second. Initial velocity is 20 meter per second. This is a shell, suppose of mass m, moving with velocity. Therefore, what about its momentum? What about its initial momentum? It would be mass into velocity. So that is 10 into 20. So it will be 200 kg meter per second, right? Now it explodes into two portions of 6 kg and 4 kg respectively. If the former, that is the 6 kg portion, is brought to rest after the explosion, we are supposed to find out the velocity of the latter portion, that is 4 kg mass. So here again, it's the case of explosion. Students always remember, a shell or a bomb explodes due to the internal forces. So net external force acting on it is 0. And we are aware, in the absence of any net external force, the momentum of this system is always conserved or constant. That is, initial momentum of the system must be equal to the final momentum of the system, right? So after explosion, these are the two fragments. Suppose this is A and this is fragment B, right? So these are the two fragments, A and B. Suppose it is of 6 kg and this is of 4 kg. Its velocity, VA, it is given to be 0. The former is just brought to rest, so it is 0. And its velocity is suppose VB, which is to be calculated, right? So, as per the conservation momentum, initial momentum must be equal to the final momentum in the absence of any external force. Therefore, students, what is the initial momentum? 200. What is the final momentum? It will be equal to momentum of this body, which is 6 into 0. Obviously, this fragment being at rest, the momentum would be 0. Plus, what about the momentum of this fragment? Momentum is mass into velocity. It will be 4 into VB. So therefore, 4 VB is equal to 200, which implies that VB is equal to 200 divided by 4, which is 50 meter per second. Clear, students? So this must be the velocity of the fragment of mass 4 kg. It was quite a simple question. So students, I hope you have really understood the concept of law of conservation of momentum after doing these questions based on that, right? So that's it for this particular session. Do join me in my next lecture then, right? Till then, bye-bye, and do take very good care of yourself. Always be happy. Thank you.